Okay, we're going to talk about measures of dispersion. And measures of dispersion are measures that they're numbers that measure how spread out the data set is. Okay, and a very simple measure of dispersion is called the range. And the range is just the maximum value minus the minimum value. Okay, so here's an example. Here's a data set, and it looks like the minimum value is 35, the maximum value is 65. And so in this case here, the range is just going to equal 65 minus 35. And that would be 30. Okay, so the range is 30, and so what that means is that the distance from the minimum value to the maximum value is 30. And that indeed, that's a measure of how spread out the data set is. So the more spread out it is, the bigger the range is going to be. Okay, and so in one sense, that does a pretty good job measuring how spread out the data set is. Okay, but the range is not the best measure of dispersion. Okay, and let me give you another example to show you why here. So let's say I have a data set that looks like this. Something like this. Okay, and let's say again the mean here is 50. So remember, the X bar is the symbol for the mean. So the mean is 50 here. The minimum value we'll say is 35, and the maximum value is 65. And so if I were to calculate the range in this case, I would get 65 minus 35 is equal to 30. I would get the exact same range for this data set. Okay, they both are spread out from 35 to 65. They both have the same range, and yet they're very different data sets. And in fact, if we think of how spread out the data is, if we think of that as kind of like how far the different values are from the mean, so this is kind of your average value, well, how far are the different values from the mean? If you look at this data set, you got a lot of the data really close to the mean. Okay, and this data set here, there's really almost no data close to the mean. It's all spread out to the ends. So most of your data is way out here in the ends of the distribution. So in one sense, this one has more spread. This data set down here is more spread out than this data set up here. And so what we would like is we would like a measure of dispersion that reflects that, where this data set would have a higher measure of dispersion. Okay, well, the problem with this, if you think about this, is that the range only takes into account two values in the data set, and those values are the minimum value and the maximum value. And those two values, as long as those are the same distance apart, you're going to get the same range. And all the other values in the data set could be doing something else. So what we would like is we would like a measure of dispersion. And you know what? I might end up calling it measures of variation. A lot of textbooks call it measures of variation. So measures of dispersion, measures of variation, that means the same thing. But we would like a measure of variation, and I might, as we go on, I'll probably call it measures of variation. So we would like a measure of variation that takes into account every value in the data set. So kind of like the mean. The mean is a formula where I plug in every value in the data set. They all get added together, and then we divide by the number of values. And so the mean here takes into account every value in the data set. And so I want to measure a variation that's going to take into account every value in the data set. And so that is what the standard deviation is. Okay, this is a measure of variation that takes into account every value in the data set. Okay, so the standard deviation is going to be a measure of variation that takes into account every value in the data set. So when you think of standard deviation, so when you think of that word deviation, kind of what comes to mind? So let's say if their behavior is kind of deviant, sometimes we think that might mean their behavior is kind of bad, but it doesn't necessarily have to be bad. It's just that there's this normal behavior kind of down the center, and your average child behaves in a certain way, but then some children might deviate from that, okay? And some might deviate just a little bit, some might deviate a lot, and they could deviate either direction from that, okay? So let me give you kind of a way of thinking about what a deviation is. Okay, so suppose you have this data set, and the mean here is equal to 50, and then you might have an x value down here. Maybe this x value is equal to 42, and then you might have an x value way up here. Maybe this x value is equal to 63. Okay, and so what you can do is you can take the difference here. So if I want to know how far 63 deviates from the mean, I can take 63 and subtract the mean, and I get 13. And so the deviation for this particular value would be 13. It's 13 units above the mean. Okay, now what about 42 here? So I could take the distance here. I would take 42 minus 50, and in this case I would get a negative 8. Okay, so you're always going to take the x value first minus the mean, and so if the x value is below the mean, you get a negative deviation, and that negative deviation just means it's, in this case, 8 units below the mean. Okay, so you can have a positive deviation if the value is above the mean, and a negative deviation if it's below the mean. So the formula for a single deviation would be really simple. It would just be, for each value in the data set, you would take the x value and you would subtract the mean. So x minus x bar, and that would be how you would represent a single deviation in a data set. Okay? So with that in mind, let me give you a formula for the sample standard deviation. So in statistics, you have populations that are really large, and you usually don't collect data from the entire population. You usually take out a smaller sample. And so when you calculate things like the mean and standard deviation, it's often the mean and standard deviation of the sample. So this is the formula for the sample standard deviation. So let x bar be the mean of a sample of size n. Then the sample standard deviation is given by the following formula. Okay, we're going to use S to represent the sample standard deviation, and it's going to be the sum of x minus x bar squared, all divided by n minus 1, and then you're going to take the square root of that. And that's going to be the formula for the sample standard deviation. Okay? Now, I know that you wouldn't necessarily know how to calculate this, because this is notation that you're not very familiar with. So, in the next video, what we're going to do is we are going to learn how to use this formula to calculate the sample standard deviation.